When most people hear the word dinosaur, they picture giant skeletons, roaring movie monsters, or enormous reptiles stomping through ancient forests. But scientifically, dinosaurs were not just big lizards. They were a diverse group of reptiles belonging to the clade Dinosauria, and they reshaped life on land for more than 160 million years. Some were tiny and feathered. Some were massive plant eaters longer than a basketball court. Some ran on 2 legs, others walked on 4, and many had horns, crests, armor, or strange display structures. Most importantly, dinosaurs were not a single type of animal, but an enormous evolutionary radiation. To understand them, we have to look beyond the movie image and see them as living creatures shaped by ecosystems, competition, climate, extinction events, and deep time. Dinosaurs first appeared early in the Triassic period, after one of the most devastating mass extinctions in Earth's history had already transformed the planet. At first, they were not the dominant animals. The Triassic world was filled with many reptile groups competing for space, food, and survival. Early dinosaurs were often relatively small, lightly built, and mostly bipedal, meaning they walked on 2 legs. Their posture was one key advantage. Unlike reptiles with sprawling limbs, dinosaurs held their legs more directly under the body. This upright stance made movement more efficient and supported more active lifestyles. Over time, these features helped dinosaurs expand into new roles, but their true rise came after another global crisis changed the balance of life on land. Around 201.3 million years ago, the Triassic-Jurassic extinction event wiped out many competing animals. This event opened ecological space across the continents, and dinosaurs rapidly became the dominant terrestrial vertebrates. In the Jurassic period, they diversified into many familiar forms. Long-necked sauropods became gigantic herbivores, browsing vegetation at heights few other land animals could reach. Predatory theropods evolved into powerful hunters with sharp teeth, claws, and keen senses. Other dinosaur groups developed beaks, heavy bodies, and complex chewing adaptations for processing plants. Their dominance did not mean every dinosaur was huge or fearsome. It meant dinosaurs occupied many of the major land-based ecological roles, from small agile omnivores to enormous ecosystem-shaping giants. For much of the 20th century, dinosaurs were often portrayed as sluggish, cold-blooded, and almost doomed by their own size. Museums displayed them as impressive but outdated creatures, like evolutionary dead ends. Beginning in the 1970s, that picture changed dramatically. Fossil evidence, bone studies, trackways, and comparisons with living animals suggested that many dinosaurs were active, dynamic, and had elevated metabolisms. Today, dinosaurs are widely understood as warm-blooded or at least metabolically complex animals, not simply slow reptiles waiting for extinction. Their erect limbs, growth patterns, and possible social behaviors point to energetic animals that could migrate, compete, care for nests, display to mates, and respond actively to their environments. One of the biggest shifts in dinosaur science is the realization that birds are dinosaurs. More specifically, birds evolved from small feathered theropod dinosaurs during the late Jurassic. This means the dinosaur story did not truly end 66 million years ago. It continues every time a sparrow lands on a fence, a hawk circles overhead, or an ostrich runs across open ground. Fossils show many non-avian theropods had feathers or feather-like coverings long before powered flight appeared. Feathers may have first served functions such as insulation, display, camouflage, or brooding eggs. Flight came later, building on features that had already evolved in dinosaur ancestors. In modern classification, birds are avian dinosaurs, while the extinct forms are called non-avian dinosaurs. The variety among dinosaurs was extraordinary. Paleontologists have identified more than 900 distinct genera and over 1,000 species of non-avian dinosaurs, and the number continues to grow as new fossils are found. Dinosaurs are represented on every continent, including Antarctica, which tells us their range was truly global. They lived in forests, floodplains, deserts, coastal environments, and polar regions. Some were herbivores, feeding on plants with specialized teeth, beaks, or enormous digestive systems. Others were carnivores, built to chase, ambush, or scavenge. There were also omnivorous species that likely ate a mixture of plants, small animals, insects, or eggs. Dinosaur diversity was not just about size, it was about lifestyle. Although dinosaurs were ancestrally bipedal, meaning their earliest forms walked on two legs, evolution experimented repeatedly with body plans. Many later groups became quadrupedal, walking on all fours to support heavier bodies or different feeding strategies. Sauropods, for example, needed four pillar-like limbs to carry their immense weight. Ceratopsians, the horned dinosaurs, also became powerful four-legged herbivores. Some dinosaurs may have shifted between stances depending on age, speed, or behavior. This flexibility shows how evolution reshaped the original dinosaur body plan again and again. The key shared feature remained the upright limb posture, which separated dinosaurs from many other reptiles and helped support their active movement and large body sizes. Dinosaurs also evolved dramatic structures that were not always about combat. Horns, crests, frills, plates, and spines appear across many groups. Some may have helped animals defend themselves from predators, but many likely played roles in display, species recognition, or attracting mates. A crest could signal maturity. A frill might make an animal appear larger or help individuals recognize their own species in a crowded environment. Bony armor protected some dinosaurs, while spines and plates may have combined defense with visual signaling. These features remind us that dinosaurs lived social and sensory lives. They were not just eating machines. They communicated, competed, displayed, and interacted in ways that fossilized bones can only partly reveal. Reproduction is another area where dinosaurs look surprisingly familiar. Evidence suggests all dinosaurs laid eggs, just as birds and many reptiles do today. Fossil nests, eggshells, embryos, and nesting grounds show that many dinosaurs built nests and returned to nesting sites. Some fossils even suggest brooding behavior, where adult dinosaurs may have protected or warmed eggs in ways similar to modern birds. Nest building appears to have been shared by both avian and non-avian dinosaurs, which makes bird reproduction part of a much older dinosaur inheritance. These discoveries shift the image of dinosaurs from solitary monsters to animals with life cycles, parental strategies, vulnerable young, and complex reproductive behavior. Size is one reason dinosaurs continue to fascinate us. Some non-avian dinosaurs were the largest land animals that ever lived. The biggest sauropods are estimated to have reached about 39.7 meters, or 130 feet, in length and around 18 meters, or 59 feet, in height. Their bodies were engineering marvels, long necks, massive torsos, pillar-like legs, and tails that balanced their frames. But giant size also required enormous amounts of food, efficient movement, and strong growth patterns. Not all dinosaurs were giants, though. Many were small, and the surviving dinosaur lineage, birds, is generally limited in size by the demands of flight. Dinosaur evolution stretched from delicate feathered forms to walking mountains. The non-avian dinosaurs disappeared during the Cretaceous-Paleogene extinction event about 66 million years ago. This extinction, linked strongly to a massive asteroid impact and global environmental disruption, ended the reign of most dinosaur lineages. Ecosystems collapsed under darkness, cooling, wildfires, acid rain, and broken food chains. Large animals were especially vulnerable because they needed stable supplies of food and habitat. Yet one dinosaur lineage survived, birds. Their smaller sizes, varied diets, flight ability, and ecological flexibility may have helped some of them persist through the disaster. So the extinction was not a total dinosaur ending. It was a brutal evolutionary bottleneck that erased the non-avian dinosaurs while allowing avian dinosaurs to continue into the modern world. The modern study of dinosaurs began in the early 19th century, when the first fossils were recognized as belonging to strange ancient reptiles. In 1842, Sir Richard Owen coined the word dinosaur, meaning terrible lizard, to describe these great fossil animals. Since then, mounted skeletons have become museum icons, and dinosaurs have taken over popular culture through books, documentaries, toys, and films like Jurassic Park. But public fascination also fuels real science. New funding, new fossil discoveries, and new technologies continue to change what we know. Dinosaurs are no longer seen as failures from a vanished world. They were successful, adaptable, often active animals, and in the form of birds, they are still with us today. If you found this helpful, please like this video and subscribe for more explainers.